In this video, we're going to look at a few more operations with complex numbers. So this is part 2 for this video, operations with the complex numbers. You guys can see the definition again here, complex number, pure imaginary. And we are going to look at graphing complex numbers and the absolute value for today. So just make sure you guys read your notes and let's try a few examples. So the first one is dividing complex numbers. On the previous video, we saw how to multiply, add, and subtract. But today we are looking at how to divide. The first thing is you have to look at the denominator. So this is what it's going to look like when you divide. You have a fraction. You look at the denominator and you are going to look for the conjugate, the complex conjugate. You're going to multiply the bottom and the top of the fraction by that complex conjugate. So the complex conjugate is when you keep the real number, -1, just keep it, and change the sign of the pure imaginary number. So minus becomes a plus 4i. And top, do the same thing. You're going to multiply by the same complex conjugate, so there's going to be -1 plus 4i. Since we have two complex numbers, we are going to use I'll use the FOIL method to multiply. So here's the fraction line. I'm going to multiply the top first. 7 times -1 is -7. I'm using the FOIL method. 7 times 4, that's 28i. Inner, that's -5i. And the last, that's going to be positive 20i squared. We do see the I squared. Keep in mind I squared is -1, so we're going to have to substitute that value. On the bottom, do the same thing. You multiply using the FOIL method. -1 times -1, that's positive 1. -1 times positive 4i, that's -4i. Inner, -4i times -1, that's positive 4i. And the last, negative times positive, that's -4 times 4 is 16. I times I squared. On the top of the fraction, you're going to combine like terms. You're going to substitute a -1 into the I squared. On the bottom of the fraction, these two cancels, and you're going to substitute a -1 into the I squared. So let's do that. Here's the fraction line. You bring down the -7 on the numerator. Combine the terms, that's positive 23i. And substitute a -1. On the bottom, you bring down the 1. Cancels. Bring down the -16 and substitute a -1. You simplify, so let's look at the top. There's the -7 plus 23i minus 20. And on the bottom, you get 1 plus 16. Combine like terms on the top and on the bottom, numerator and denominator. So it's going to be -27 plus 23i over 17. You always want to check if you can simplify the fraction. You look at the three numbers and check if they have a common factor. And they do not. So here's my answer. Next one, same thing. We don't have a complex number per se on the bottom, on the denominator, but it is a pure imaginary. So we just multiply by the conjugate. So you change the sign of the pure imaginary, so that's positive 2i. On the top, change the sign, positive 2i. Change the sign of the denominator. So you multiply. So here's the fraction line. Multiply 2i times -2, that's -4i, and positive 2i times positive 3i is positive 6i squared. On the bottom, there'll be -4i squared. Substitute a -1 for the I squared. So you bring down the -4i plus 6, substitute a -1. On the bottom, substitute a -1. So we have -4i minus 6 and +4. Real number goes first, so -6 minus 4i over 4. Now on this one, look at the numbers, 6, 4, 4. I'm looking at those three numbers. They do have a common factor, which is 2. So you can reduce by 2. You divide everything by 2. So 6 divided by 2, that's 3, so -3 minus 4 divided by 2 is 2i, and on the bottom 4 divided by 2 is 2. So here's my answer. Alright, so we're moving on to how to find the absolute value. On your notes, you do have the, you can say, formula to find the absolute value. So you have the symbols here, 2 vertical lines, absolute value. You have a complex number inside. You're going to use this formula, the square root of real number squared plus imaginary number squared. Real squared plus imaginary. So here's the absolute value. I see my vertical lines, complex numbers inside. So I'm going to take the square root here. I'm going to take my real number, which is 4. I'm going to square it. I'll put parentheses here so you know that I'm squaring that. Plus, that's from the formula. There's the plus. And I'm going to take my imaginary number, which is also positive. So 2, not the I. Common mistake, students like to carry the I in the formula. Don't do that. Just take the number of the pure imaginary and square it. So you take the square root, simplify what's inside. So that's 16 plus 2 squared is 4. Add the numbers, so that's 20. You can simplify the square root of 20, not decimals, but you can break it down. 2 factors that multiply to 20, and one of them is a perfect square number. So that's 4 and 5. The square root of 4 is 2, so you put it outside of the radical, and the 5 stays inside. This is what we call the exact value of the absolute value, because it's not a decimal. Sometimes decimals you have to run off, but that's not exact. This is the exact. For the next one, same thing. You're going to take the real number and imaginary number, and you're going to square them. So here's the square root. Here's the real number. You square it, plus imaginary number. Square it, no I, once again. You don't use the I. So you have 16, -4 squared 16, plus 9. 3 squared is 9. Add the numbers. So that's 25, and 25 is a perfect square number. We know the square root of 25 is 5. So here's the answer. So you can have a radical form, you can have a whole number. If that happens, it's okay. Now part C, same thing. We don't have a real number, we do have imaginary number. So when you are missing one of the numbers, for example here is the real, you just put a 0 for the real. That's the one we're missing, squared. If you're missing the I, the imaginary, you put a 0 for the imaginary. But here we have a -7 squared. There's no I, again. You don't use that in the formula. Square the 0, so that's 0 plus square -7. That's positive 49. And you add, so that's 49. And once again, 49 is a perfect square number, which is 7. There's no I in my answer, just 7. Okay, so the next step is have to graph. We can graph imaginary numbers. One thing you have to understand about the coordinate plane is what happens when you graph complex numbers. First of all, the x-axis that you know, which is the vertical, horizontal line, is the real axis. So instead of x-axis, now we call it the real axis. The vertical line is going to be for the imaginary. So you knew it was the y-axis, but now it's the imaginary. One thing that I tell my students is, if you look at the last letter of the word imaginary, you see the y. So imaginary y-axis, which is the vertical. That's one way you can memorize what is the imaginary number axis. Now, origin. Origin is 0, 0. You guys know that from coordinate plane. But now, since this is a complex number, is 0 plus 0i. So instead of 0, 0, it's 0 plus 0i. The good thing about graphing complex numbers is that you graph them same way you graph an ordered pair. You just have to know how to set up your ordered pair. So notice that I do have a coordinate plane. I'm going to change the name of the axis. It's not an x anymore. It's a real axis. So let me put real here. And for the y, remember that's the letter for the word imaginary. So let me use that letter y. And I'm going to try to fit the word imaginary. Imaginary. Oh, works nice. Imaginary. So there's the y axis. Imaginary. I'm going to plot a few things here. So 3 plus 0i. This is how you set up your ordered pair. You have your real number instead of your x coordinates, and you have your imaginary number instead of your y coordinate. So my real number is the 3, my imaginary number is 0. You guys know how to plot that point, so go ahead and plot it. So we go 3 to the right, 1, 2, 3, and we stay there. So that's the first one. That's the complex number. Let me put A here so you know that's point A. Point B is 2i, so notice we don't have a real number. So I'm going to set up my coordinate point, real and imaginary number. So there's no real, so 0. Imaginary number is 2. So 0 up 2. So there's point B. For the next one, let me talk about point B. Since point B is on the y-axis or the imaginary, now it's the imaginary, we call that pure imaginary number, okay? There's no real number. For the next one, I'm going to take my real number first. So there's the -2. My imaginary number is a 1i, so -1. So you go 2 to the left, 1 down, and there's point C. For the next one, my real number is 3. My imaginary number is 2. Don't worry about the I. So 3 to the right, 2 up. And there's point D. For the next one, that's my real number, -5. Imaginary number is 0. There's no I. So 1, 2, 3, 4, 5 to the left. There's point E. And the last one, it says plot the conjugate of point C. So let's look at the conjugate. Let's go back to point C. Point C is -2 minus I. So the conjugate, let's write that down first. The conjugate is -2 plus I. You change the I, the sign, keep the real number. And to plot this point, you take the real number, -2, and the imaginary number is +1. So you go 2 to the left, 1 up. So this is point F. And I want you guys to look at point C and point F. C and F. F is the conjugate of point C. So when you look at the points, first of all, you have to understand that those 2 points are reflection of each other. C and F are reflection. F is reflected over the x-axis or the real axis from point C. So F and C are conjugates. They are reflections of each other over the real axis, which is the x-axis.